we will explore another way of mixing up conditions that may be required sometimes in your scripts. I will show you how you can nest if conditions and why and how are they different from simply having multiple conditions. Let's say that we want to generate a matrix of ones. I have prepared some sizes of dimensions, rows and columns, and in order to generate the matrix of ones, we want to check if that matrix will be a square matrix. For this to be true, the rows and the columns must be equal. And we also want the matrix to be of at least 3 by 3 size. So we will have two conditions. The first will check if the matrix is a square matrix, meaning rows are equal to columns. And we also want the matrix to be at least 3 by 3. Since the rows and the columns must be equal, we only need to check one of these sizes. So if rows is more than or equal to 3, we are satisfied. If that is true, we want to create our matrix of ones, rows and columns. And let's see if it's going to work. There we have it, 4 by 4 matrix of ones. If it's now a non-square matrix, we don't get the matrix. If we use 2 and 2, we still don't get it. If we use 3 and 3, we get our matrix. But let's say that we also want to check the number of elements in the matrix, and if that matrix has more than 20 elements, we want to multiply all of these elements by 9. So it's not going to be anymore a matrix of ones, it's going to be a matrix of nines. Within our if condition, we are going to say if numL matrix, you know that the numL function will give us the number of elements in the matrix, is more than or equal to 20, we want to multiply everything by 9, like that. And now we have an if and another if inside this if. Let's see what will happen if we run it. We still get a matrix of 1 by 1. And you might be wondering, why did we split the conditions into two separate nested ifs? Why didn't we just create one big statement to cover all of our conditions? Well, you immediately understand it as soon as we start testing our code. Now, let's try with different rows that are less than 3. So we have a non-square matrix and the rows are less than 3. This will not produce a matrix at all. If we try with rows and columns that are more than 3, we still don't get a matrix, that is obvious. If we now try with rows and columns that are equal, that will produce a square matrix, 4 and 4 for example, we get a matrix of ones. But if we now make the rows and the columns 5 and 5, we will get something different. Let's unsuppress the output here. So let's run it. As you can see, first we get our matrix as ones, but then we get a second output, and now this matrix becomes a matrix of nines. The difference here is that when we nest conditions, we make our code even more flexible. This way, we have a set of conditions in our main if, these conditions here. If these conditions are true, whatever is in the body of the if will be executed, so the matrix here will be created. Then it will get to the next if, look at it as the next level, and if that turns out to be true as well, its code will also be executed. But if the second if turns out to be false, the code from the first if that is outside of the second if is still going to be executed. So this piece of code is dependent on both of these ifs, but this piece of code is dependent only on the first if. We can't achieve this neither by putting all the conditions in the same if or by separating them into two different ifs, because our first if is the if that generates the main matrix, and the second if is only modifying it.